A quadratic function has the equation y equals, it's factored, x plus 2, x minus 3. When comparing the rates of change at the points x equals 2 and x equals 3, which statement is correct? Now, thing number one, it mentions rates of change. It mentions nothing about average rates of change. So if you're thinking f of b minus f of a, stop it. Thing number two, this is a calculator problem. So let's pull up a picture of what you see on the calculator. Now, what I'm doing here is rate of change is another fancy word for slope. So it's asking me, what's my slope going to look like at x equals 2, there, and what's my slope going to look like at x equals 3? Well, at x equals 2, I can't tell exactly what it is, but I have a positive slope. What I do know is that x equals 3, right here, that slope is steeper. Now, how do I know that? This is concave up. And when it's concave up, the rate of change is always increasing. So what I can say is the rate of change for 3 is greater than the rate of change for 2. The rate of change is greater at 3 since 3 is greater than 2. That's true in this case, but not necessarily true, so I'll put a question mark right there. The rate of change at x equals 3 will be 1 more since 3 is 1 more than 2. I don't think that's the case. By using x values close to 2 and x equals 3, the rate of change is greater at x equals 2. That's not true. By using x values close to 2 and x equals 3, the rate of change is greater than at x equals 3. I guess that would be true. Although A is technically correct in this case, A is not always true, so we can't select A. So in this case, B is true because I can use these points. But I just used a picture and I used common sense. I'm not going to go to second table and try to get values close to 3. You could, but I'm not going to do that. Estimate the rate of change at x equals 1 for the function f of x equals negative 1/2 x squared plus 3x minus 1/2. Now, we know the average rate of change. The average rate of change, the AROC, is going to be f of b minus f of a over b minus a. This isn't asking for that. This is asking for the rate of change at the very moment when x is equal to 1. Well, this involves calculus, and we don't know calculus yet, so we're going to use our calculator to give us a trick. See, we don't know the exact rate of change at 1, but what we could do is we can allow an interval that's awfully close to 1, like how about 1 and 1.0001? See, that's not going to give us the actual exact rate of change at 1, but it's going to give us the average between 1 and 1.0001, which last time I checked, 1 and 1.0001 is awfully close to each other. So that's how we're going to handle this. So what I'm going to do is I'm going to run to my calculator. I'm going to find out f of 1.0001 minus f of 1 over 1.0001 minus 1. So let's take a step aside and do that. All right, so the way we're going to handle this is we're going to type in our function right into here. We're going to type out negative 1/2, so negative 1 divided by 2. You could do 0.5 if you want. Really, it makes no difference. Negative 1/2 x squared plus 3x minus 1/2. So I'll do 0.5 because, fractions make me nervous. When I take a look at the graph, I'm trying to find the instantaneous rate of change at 1, which means, whatever my slope is at 1 is going to be my guy. And it looks like it could be a positive 1, positive 2, positive 3, but I'm not so sure. So what I did is I set up 1.0001 and 1. So I need to find both of those. So second calc is going to let me find a value at a specific thing. I'm going to use this to find the value of 1.0001 by hitting enter and then typing out 1 0.0001, hit enter on that, and that gives me 2.0002. Okay. Now, if you remember from the problem, we said that we're going to do f of 1.0001, which is that, minus f of 1. So what's an easy way of finding out what f of 1 is? Go to second table, and there's f of 1. It's 2. So the equation that I'm going to set up is that f of 1.0001, so let's go back here and set that up, which was 2.0002 minus f of 1, which is 2, all of which divided by 1.0001, so let's throw that into parentheses, 1.0001 minus 1, close parentheses on that, and we get 2. So again, if we were to look at this graph, we can kind of see that at 1, if I were to draw a line there, it might have a slope of 2. Maybe. I don't know. Use your imagination. But that's what we're going to get to dunzo. All right. So after all of that, we ended up getting what? 2.0001. We ended up getting 2 here. Oh, actually, that was 2.0002, wasn't it? I'm trying to remember what I got. 1.0001 minus 1. When you did the math, you got 2. And so we said 2. And again, I wasn't really able to draw anything on the calculator, but what we saw was a picture that looks like that, a perfect parabola with a bump over here. And so at 1, which we could say that's 1, we had some type of slope, and that slope kind of looked like 2. So that slope is going to be 2. And the rate of change is a fancy word for slope, because doesn't that just look like the slope formula? It does. It should, because it is. All right, so we've got ourselves a random calculator problem. Consider the polynomial function x cubed minus x minus 2x squared plus 2. Which of the following occurs at approximately x equals 0.67? So I'm going to step to the side. I'm going to let the calculator do the job, come back, and see what happens. Okay, so I'm supposed to graph this guy right here. I already typed it in because, saving some time. When I go to graph, it gives me a nice little cubic right there. And I care about what happens at 0.67. Now, at 0.67, I really can't see it that well. So what I can do is I can zoom in by hitting zoom to, hitting enter, and I can kind of see what happens at 0.67. If that's not good enough for you, you can hit second calc and calculate the value at 0.67. Now, what we see appears to be a change in concavity, which is what happens when I go to the dentist. At 0.67, it looks like an inflection point. So let me answer the question based off of what I see here. So basically what you saw is a picture that looks like this. When we found the value at 0.67, it gave us that which appears to be an inflection point. And in this case, an inflection point takes us from going concave whatever to concave whatever. And in this case, it goes from concave down to concave up. And so that's our guy. Ooh, we've got ourselves a calculator problem. Mathematicians at a water purification company have created a function that models the cost C of removing P% of the impurifications from 1,000 gallons of water. The function is gross. Evaluate and interpret P, or the limit, as P approaches 100 from the left of CFP in the context of this problem. So clearly we're going to want to use a calculator for this one. So I'm going to take a step aside and take a look at what the calculator has to look like. Okay, let's graph this gross, terrible problem. Let's hit y equals negative. Don't make the mistake of typing out minus sign. They mean different things according to TI. 0.1 x squared plus 32 x plus 1043, close your parentheses, and divide that by parentheses x minus 100. Now, we care about what happens when x approaches 100. So if I graph it, I'm not going to see at all what I need to see because we only go out to 10. So let's do this. Since I care so much about what happens at 100, let's make a window going from 50, that's 500, 50 to 150, just for funsies. Okay, this is rational, so I kind of probably need to give myself a nice big window, and that didn't seem to do it. So let's zoom out, zoom 3, enter. No. So let's zoom out again. Zoom 3. There we go. All right, so there's 100 right there. See how it's blinking 100? What the question is asking us is the limit as p approaches 100 with a little negative symbol. That means from the left side. So if I go from the left side, knowing very well that I have a vertical asymptote at 100, from the left, I shoot up right to 100. So that's the graphical interpretation of what this problem is. So let's go back to the actual question and see if we can answer it. All right, so according to the picture that we got, we have this rational looking thing where magic happens at 100, which makes sense because at 100, bad news happens. We care about what's happening coming from the left side. So coming from the left side, we go up to positive infinity. So looking at all of our options here, no, no, yes, no, and here's why. The company will pay more as they remove more impurifications and will never remove 100%, which makes sense. You're never going to remove 100%. So that's what we get for this one. Kind of a tricky problem, very strange indeed, but we did it. A t-shirt is launched straight up into the air from a cannon with an initial velocity of 50 feet per second. From a height of 4 feet. The height of the t-shirt can be modeled by this function right here. Man, it sounds like we're at a baseball game or something. Good old t-shirt cannon stuff. T is time in seconds. T-shirt's launch, blah, blah, blah. Which of the following is a true statement? So we have ourselves a quadratic. It's going to look like this. Okay, and what I need to do is I need to use this information to run to a calculator and find out which of these statements are true. So be right back. All right, so we got the old traditional launching t-shirts in the air type problem. So let's go to y equals and type it out. This is a very typical gravity equation. When you see that negative 16x squared or t squared in this case, x squared is the same thing, that tells you gravity. Then you have plus 50x, and that plus 4 means that you're 4 feet in the air when you launch this out. Okay, that would be your y-intercept, which means at 0 seconds, you're 4 feet in the air. When I hit graph, I'm not going to get a whole lot. See? So what I need to do is I kind of need to figure out where some of my major numbers are. Looks like we start at 0-ish. And after 1, 2, 3-ish, we hit the ground again. So t-shirt's in the air, comes up, goes back down after about 3 or so seconds, hits the ground again. So what I want to do is I'm going to create a window that gets me better x values. So I'll do -1, because I can't just completely let go of the past. And I'll go to 4, and I'll hit the graph, and at least I have a good indication as to where I begin and where I end. Now, looking at the 4 options that I have, option A says the t-shirt will reach a maximum height of 50 feet, approximately 1.875 seconds after launch. So and looking at these, the height is always going to be, looking at B, the height's not going to go any bigger than 50, it looks like. So I'm going to go back to my window. I'm going to change my Y max to 55 because I'm expecting it to peak out around the 50s. And the Y min, I can leave it like 0. I'll make it -5 just to have some underground stuff going on. And when I hit graph, I get a much better visual. There you have it. Now, A says the t-shirt will reach a maximum height at 50 feet at 1.875 seconds. So I need to make sure that whatever this guy is, it happens at exactly 1.875. This is my maximum. So I'm going to hit second, trace. I care about my maximum, so I'm going to either hit 4 or go to 4 and hit enter, and I need to calculate my maximum. So my maximum's right around here. I'm going to go to the left of it, hit enter for my left bound. I'm going to go to the right of it, moving, and now I'm going back down. So my maximum is going to be in between those two lines right there. Hit enter. And my maximum happens at 1.5624, and the maximum is 47 or 43. So that's not A at all. That's actually B. And B says the t-shirt will reach a maximum height of 43 feet. So 43, yeah, close enough. And it happens at 1.563, which when you round that or whatever, it's close enough. There's a little bit of wiggle room with these. So yeah, my guy is actually not A, it's B. And if you look at your picture, C and D don't even make any sense. That is just crazy talk. So my answer for this guy is going to be B. It's going to be Bay, as one time Justin Timberlake once said. Remember that song? Okay, back to the problem. And I'm back. And when trying to see if A was true, it ended up B was true. So yeah, kind of a, you didn't have to show any work there, not a lot of craziness. Just, throw it in your calculator and click a few buttons and the answer is B. It's not A. The value of stocks on the market typically fluctuates over the course of a day. Now, suppose a particularly volatile stock's daily value can be modeled by this terrible function where H represents the hours after the stock market opens for early trading. The stock market is open for 9 hours, so the domain is that. That's going to be helpful because we're going to have to throw this into a calculator. Approximately how many hours after opening does the stock reach its lowest value? So I don't know what this guy looks like. It's a quintic. So at some point, I'm expecting this to happen between 0 and 9. And what I'm going to do is I'm going to try to throw that in my calculator and find out what that minimum value is and what it represents to in this real world problem over here. All right, so we have this terrible equation to plug in. So, we're just going to plug it in and make sure that instead of H, we use X and just go from there. So X to the 5th minus 20X to the 4th. Move to the right. Plus 146 X to the 3rd. 1, 4, 6. X to the 3rd minus 484 X squared. Probably should have typed this in ahead of time. That's all right. The more time that I have on screen, the more money I make. Sweet YouTube money. Plus 717X. It's the Lancaster area code. And then last but not least, we get 15. All right, it gives us a domain of 0 and 9. So what I'm going to do is I'm going to go to my window, and I'm going to choose my window. Instead of using 0 and 9, I'll give it some wiggle room, -1, and I'll leave that at 10. So let's hit graph and see what we have. Terrible. Absolutely terrible. Now here's why it's absolutely terrible. These numbers are huge. So let me set my window. I have a couple 700s. Let me actually look at my, I was hoping that if I look at my answers, it would give me a good idea as to what numbers that I have that are super big. Why don't I hit zoom out and just keep hitting zoom out until I see things either bottom out and that's what I want to see. I want to see it bottom out because it asks that question. It wants it to reach its lowest value of the day. So I need to see the bottoming out. Don't see that. So zoom out again. Zoom 3, enter. I don't see much there. Zoom 3, enter. Ugh. Zoom 3, enter. Yeah, this just ain't good. What if I set my window now that I know what I know? Let's set that window back to 0, or better yet, -1 and 10. Maybe that gets me a much better picture. Let's see, graph. Look at that. So sometimes you just have to play around with the calculator a little bit. It looks like Whatever this number is, give or take, is going to be my minimum. So I'm going to hit second. And just because I need to find the minimum between 0 and 9, let's do the minimum between 0 and 9. So let's go all the way over to 0, all the way over to 0. Or is it? Yeah, 0 and 9. So I'm going to go to 0. Perfect. Enter. I'm going to go all the way to the right side to 9. I probably didn't need to zoom out to do this, but at least I got a nice looking picture. Boom. And my minimum, which I thought maybe would be at 0, is actually not at 0 at all. My minimum is at the x value of 7.11. So approximately how many hours after opening does this stock reach its lowest value of the day? 7.11, 7-Eleven, is much, much, much closer to 7 than it is to 8. So we are going to say that C is the answer we're going with for this guy right here. So after doing all of that, the lowest value was 7-ish. So we said that's close enough to 7. So, tricky problem. The biggest mistakes that are made is just typos. You just have to be careful. The volume of a spherical water balloon can be calculated by the formula V equals 4/3 pi r cubed, volume of a sphere. A variety pack of water balloons contains balloons that, when filled completely, the range of the volume is from 65 cubic centimeters to that cubic centimeters. Which of the following measurements would be inappropriate for the minimum and maximum diameter? So this is a calculator section, and the reason why this is a calculator section is we have pi, we're going to have the cube root. So what I'm going to do is I'm going to run to my calculator, and I'm going to try to find out what happens when I replace V with 65. So I'm actually going to do the whole thing straight on my calculator, knowing very well that my first step is going to be dividing by 4/3 pi on both sides. So I'll run to my calculator, see what happens when I do this. That will give me one of these options. And once I have the other option, I'll probably go a different route to see if the other option is the correct option. So I'll be right back. Okay, so this problem right here, we're basically using our calculator to do the heavy lifting for us. There's two ways that you could approach this. You can plug in your answers and see which one gives you what you want, or you can go backwards, which is what we're supposed to do, and I'm going to go backwards. So I need to test out a volume of 65. And so if V is 65, in order to get r cubed by itself, I have to divide out 4/3 pi. When I do that, I'm going to use more parentheses than may be necessary. And actually, I don't think it's necessary. That double parentheses seems off-putting, but trust me, more parentheses is useful. I don't want to make the calculator believe that pi lives in the numerator or whatever. That's the guy I get. Now, r cubed equals that. I need to take the cube root of that, and I take the cube root by hitting Math 4, which is the cube root button. Don't feel like typing that number in, so I'm going to hit second, negative symbol, and the cube root of that gets me 2.5 basically. Now my radius is 2.5-ish. They don't want a radius, they want a diameter. So in order to find the diameter, I'm going to multiply U by 2. And so the diameter that would give me a water balloon of 65 centimeters cubed would be 5 centimeters, which gives us our answer right away at B. Now I'm paranoid, and I want to make sure that I did it right. So let's do this. Let's go forward this time, or backward, or however you want to view it. Let me test to see if B is correct by using the maximum diameter of 10. So what I'm going to do is I'm going to plug in a diameter of 10. So if by plugging in a diameter of 10, 4/3 pi, here's the pi button. If the diameter is 10, I'm not going to use 10. I'm going to use 5 to the third. Now, if all goes well, it should get me a number awfully close to 524, which it did. So my answer is definitely going to be B, and I made sure I did it right the first time, and I just kind of double-checked using the second route. Fun. And I'm back, and it looks like it is B. So you have to be careful. The whole thing that throws me off is the diameter phrase. So if you're not careful with the diameter, it's going to blow up in your face, much like this water balloon. Hee hee. Like and subscribe. A patient receives a dose of painkiller. The function p of t equals, in the numerator, 2t squared plus 10t, denominator t cubed plus 1, and it models the amount of painkiller in the bloodstream over time. T is hours. P is painkiller in milligrams. It's a calculator problem. It's a calculator problem. We're going to need it with this ugliness. So part 1 is going to be find p of 2. Part 2 is going to be finding the average rate of change, and part 3, also known as C, is going to be the maximum amount of painkiller. So let's whip out a calculator, do each part at a time, see what we end up with. All right, so first things first, we have to plug in this formula. Whenever you're plugging in a formula, two things in this case, t's or x's, that's fine. But thing number 2, since we have a fraction, let's make sure we wrap the entire numerator in parentheses so that we have 2x squared plus 10x all in one parentheses. Then we can divide t cubed, so x, we'll do math 3 for cubes faster, plus 1. All right, hitting graph. There you have it. Now, what we're going to do is part number 1 is asking us to find p of 2 and explain your solution in context. Two ways that we could do this. The easiest way to find p of 2 is by hitting second table and going down to 2. That's our p of 2, which is 3.11111. So let's go back to our slides and write out 3.11111. All right, so we ended up with 3.111 going on forever. And what that means in context means after 2 hours, we had 3.111 milligrams of painkiller in our bloodstream. So 3.111 milligrams of painkiller in the bloodstream at 2 hours. And so we'll write it out that way because we don't have space to write everything else. B is asking us to find the average rate of change from t equals 1 to t equals 2. Let's write out B here because I, again, stole this stuff from the internet and I didn't give myself a whole lot of space. The average rate of change formula is f of B minus f of A over B minus A. So in this case, what we're going to do is we're going to find out what f of b is, which we already did. If it's 1 to 2, that would be like an a and that would be like a b. So we know what f of b is. We know what f of 2 is. Minus f of 1, we don't know what that is. All over 2 minus 1. So let's run to our calculator and figure that out. Part 2 of this is asking us to find the average rate of change between the intervals 1 and 2. So I'm going to go back to my table. Second graph goes back to my table. I'm going to use the values for p of 2, which I already found out to be 3.11111, and p of 1, which was 6. So I'm going to use 6 and 3.11111 in that order. So while I'm here, I might as well do it because the numbers are friendly enough. Parentheses 3.111 minus 6 all over 2 minus 1. So divided by 2 minus 1, I think I can handle the 2 minus 1 part, but I'm typing it out anyway because it takes time. And we get negative 2.889. So let's go back to our slides and figure out what that means in the real world. All right, so the calculator reminded us that that was 3.111 minus our new value, which was 6, all over 2 minus 1, which ended up being 1. Typing that out in our calculator was negative 2.889. Now, what that means is at this moment between hours 1 and 2, we lost 2.889, lost because it's negative, milligrams of painkiller. So that's the value that we get. And again, that means in the real world that we went from 6 to 3.111 milligrams of painkiller in our bloodstream. And so, you know, that's the rate per the 1 hour that we had. Now, C is asking us to find the maximum amount of painkiller. And so we're going to use our calculator to use the maximum value and find out what we get. Our last thing we have to do is find the maximum amount of painkiller. So let's go back to our graph. And we have this picture where when time equals 0, and by the way, we don't care about negative time because that doesn't exist in the real world. It shoots up and then it comes back down. All right, so our max lives right around here somewhere. The way we can calculate our maximum is we go to second, calc, and use the maximum value 4. So obviously it comes up and it goes back down and it never, reappears. So I'll use 0 as a left bound. I'll use, I don't care, 6 as a right bound, enter. And so it's going to tell me my maximum is going to live between 0 and 6, which looks to be the case. So hitting enter one more time tells us that a maximum occurs at 8.51 hours. And that maximum is going to be 6.161, I think was milligrams. So let's go back to our slides and write all that stuff out. So part C, the maximum value ended up being 6.161 milligrams, and that happened at 0.851 hours. So calculator problem, lots of fun. I hope you'd enjoyed it as much as I did. A rectangle is inscribed a circle with a diameter of 12. Here's my rectangle living inside, touching the outside of the circle. Diameter right there is 12. It gives us a width of x, tells us the other width is the square root of 144 minus x squared. They get that from the Pythagorean theorem just for fun. The function a of x is that guy, x times the square root of 144 minus x squared. So again, that comes from, that times that area formula, and that models the area of the rectangle. Great. What is the restricted domain of the function? This is asking us what values am I allowed to plug in? Well, first things first, we're looking at this rectangle right here, and this rectangle is going to tell us what we're allowed to plug in. Now, if we're going to represent x as a side, you are absolutely not allowed to plug in any negatives because you can't have a negative side, so negatives don't count. I also can't have a side that is 0. But I could have a side that's 0.1. It would be a very skinny rectangle, but I could have a side that is 0.1. So basically, as long as it's greater than 0, I'm allowed to plug it in. Now, what's the largest value I'm going to plug in? Well, as we see this square root right here, that tells us right there that if I have 144 minus something, that at some point there's a possibility that I end up with a negative square root, and you can't have negative square roots. So what number would make this square root equal to 0? 12. Because 12 squared is 144, and 144 minus 144 is 0. So does that mean 12, put a little bracket there, is going to be the absolute largest number that I can plug in? No. I'm not allowed to plug in 12. I'm allowed to plug in 11.99999, but if I plug in 12, then all of a sudden I'm saying I have a right triangle with a hypotenuse of 12 and a leg of 12, and geometry says that's against the law. So my restricted domain is everything from 0 to 12, not including 0, not including 12. Yippee. Part 2 is asking us what's the restricted range of the function. In other words, what is the largest and smallest possible values that I can get when I plug in 0 or something close to 0 and 12 or something close to 12. So I'm going to run to my calculator. I'm going to plug numbers in that are awfully close to 0 and plug numbers in that are awfully close to 12 and see what I end up getting. All right, so let's go to our calculator and type out this function. We've got x times the square root of 144 minus x squared. Now, what we know is our domain is everything from 1 to 12. So from 0 to 12, not including. So let's actually change our window and make it like -1 to 13 so we can see what we need to see. Okay? Boom, graph. Now it shoots way up here, so maybe let's maximize the window to, I don't know, 100 and see if that seems to be good enough. Hit graph again, and that does seem to be good enough. Oh, how nice. Now notice how it cuts off at 12. That's because we already know we're not allowed to plug in 12 or anything after that. Now, why doesn't it cut off there? Well, because our calculator doesn't realize we're doing a real life problem. So, it doesn't realize we're doing like negative x stuff. Okay? Now, what I need to do is I need to find my range. Without plugging or typing anything in, I know that my range is going to be from 0, but not including 0, to 199. So my smallest value, I already know what's going to happen. It's going to go through 0. My smallest value is 0.000001. So my smallest range, if I have like the skinniest triangle, is going to be 0, just not including 0. So I'll make sure I write that down. Now, in order to find what my maximum range is, I have to go find my maximum. So I'm going to do second calc. I'm going to set a range for the maximum. And it looks like it's going to happen between, basically, I mean, I'm at 6, so I might as well hit enter for that. And as long as I go to the right of the bump there, hit enter on that, my maximum is going to live somewhere in between. And my maximum happens when x equals 8.4, blah, 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 blah. But that maximum value is 72. So my range is going to be between 0 and 72. So let's go back and write that out. All right, so what I got was basically 0.000001. So I'll say 0, but not exactly 0. And pretty much 72, but not 72. It's got to be smaller than 72. So my smallest area is going to be like 0.00000, and my largest possible area is going to be like, 79.99 or 71.9999999. What is the maximum area of the rectangle? Well, let's go back to our calculator, type that in, and see what the maximum area is. Hey, what's the maximum value? 72, stupid. Go back. Well, I didn't really need to do that because I did that in part B. So 72. I don't know why I did that. Dummy me. But, anyway, thanks for watching. The data shows the salary in thousands of dollars for employees given their year's experience. So we have this information right here, and it looks like it's a calculator problem. So what we're going to do is let's throw all of this stuff into a calculator. All right, after we're done throwing it into a calculator, we'll answer these 3 questions. And it's asking us to use regression. So rather than doing the whole, let's see if this adds up and do that thing, let's let our calculator do the job, because I have a feeling it's not going to be absolutely perfect. So let's just plug it in to our calculator and see what our calculator gives us. All right, so let's type some of these numbers in. Stat, edit. Now, I think that what I said before is, rather than counting, if you're already noticing already, I really can't do the, hey, let's count and see how far apart these guys are, because these numbers are not equal length input value intervals. So forget what I said back there 30 seconds ago. 2, 4, 5, 8, 9, 12, 15. Then we got 48, 54, 58, 68, 73, 80, 88. All right, no mistakes at all. First thing that I have to do is figure out if this is linear, quadratic, or cubic. So why don't I graph these points on the graph? Now, hitting graph won't do anything for me. What I have to do is I have to hit second, stat plot. I have to turn the stat plot on. And already what it's going to do is it's going to give me the dots according to the stuff that I plugged in. Before I hit graph, since I'm using stat, I need to go to zoom first and do zoom stat. So go to 9 and we'll see our dots. Now those dots aren't in perfect order, but you know what? They look pretty linear to me. So we're going to go with linear for that one and write that down. All right, so basically the dots were in a nice straight line, not perfect, but good enough. So I'm going to circle linear for that one. Now that I know that it's linear, when it asks me to write an equation of the regression curve, I'm going to use linreg and see what equation I get in my calculator. Now part B is asking us to find the equation of the regression curve. We know that this is linear. So let's quit out of this. Our points are still in the thing. Let's go to stat, calc, and use linreg. Use 4. So when I go to 4, and since, by the way, C is asking me to use this equation to plug in 11, what I'm going to do is when I go to store regression equation, I'm going to hit vars, y vars, function, y sub 1. And what this will do is this will store whatever equation that I get into y equals, so I can do part C without having to type out the whole world. So if I hit enter, it gives me my equation. And so when I round it to 3 decimal places, it's going to be y equals 3.137x plus 42.349 end. Mr. Calculator says that the equation is y equals 3.137x plus 42.349. That's my equation. Use that equation to predict the salary of an employee with 11 years experience. So I'm going to throw that back into my calculator and see what I get. Now, since we stored that equation into y equals, if I want to find out what happens at 11, all I have to do is hit second table, go down to 11, and see what number I get. And that number I get appears to be 76.8603, blah, 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 blah. So when I write that out, I have to remember this is in thousands, so I'll make sure I account for that. But that's how I do this problem on my calculator. Easy peasy. Now, at 11, my calculator gave me something like 76 point blah, 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 blah. But this has to do with 76,000 blah, 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 blah. So the number in my calculator was 76.86036,036. That translates to $76,000, $860.36. Baby, that is a nice bit of coin. A linear regression model is used to construct a function model P that models the price over the given years. If t equals 1 corresponds to 2012, t equals 4 corresponds to 2015, and this pattern continues, which of the following defines the function P? So I'm awful at these, so I have to write this out. 2012 is 1. Which makes 2015 4, which makes 2018 7, which makes 2019 8, which makes 2020 9, which makes 2022 11. Never forget. All right, so let's throw that in our calculator and see what happens. Stat, edit. Let's type in those awful, awful, awful numbers. The numbers that we wrote before were 1, 4, 7, 8, 9, 11. Forget. Then we end up with the other numbers, which were 7.96. Was it 96? Yep. 8.17, 8.97, 911 again, never forget, 916, and 1012. 10, 12. This problem is asking us to find linear regression. So let's go to stat. Let's go to calc. Let's hit 4. I don't need this equation again, so I'll just hit enter, not need to store it. And I end up with 0.206x plus 7.540 or 7.541, which appears to be A according to our problem. Okay, it's A. Thanks for watching. Bye. The table above shows wind speed in miles per hour and the amount of electric power in watts produced by a wind turbine for the interval 0 to 50. Boom, boom. Okay, I don't have 50, but I have that much. Using regression, find the equation of a third-degree polynomial. Third-degree polynomial regression is cubic regression. So I'm going to do that in my calculator. And then what I need to do is I need to find out what happens when I plug in 50. So I'm going to do cubic regression and then plug in 50. And when I do this, I'm going to find out that the cubic regression isn't pretty, and there's going to be a little shortcut that we could use to make life easier. Cubic regression. So let's start by hitting stat, edit, and just typing away. We've got 0, we've got 11, we've got 18, we've got 24, and we've got 28. You move to the right, we've got 0, we've got 1.2, we've got 5, we've got 12, and we've got, last but not least, Brian Dawkins, 20. Now, I'm going to make believe that I don't already know what's going to happen, and I'm just going to do the whole cubic regression thing. Second quit, and I'm going to hope and pray that my answer is lovely. So I'm going to go to second quit, I'm going to go to stat, I'm going to go to calc, and I'm going to go to 6 cubic regression, calculate, 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 enter, 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 and gross. Okay, pretty bad, isn't it? Now, my goal is to find out what happens when I plug in 50. I really don't want to have to type any of this out and plug in 50. So let's pretend that I didn't do cubic regression. Let's hit the rewind button. That's me hitting a rewind button. It's a sound effect. Now, I'm going to pretend that I'm doing this all over again, blah, 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 blah. I'm going to second mode. I'm going to quit. I'm going to go to stat. And I'm going to assume that my equation is going to be bad. I'm going to go to cubic regression. Now, if I'm going to plug in 50, what I want to do is I want to store this formula into y equals. And so this is what I'm going to do. I'm going to go to store reg eq, which means regression equation. I'm going to go to vars. I'm going to hit right to y vars function y sub 1. And what this is going to do is this is going to store my equation in y sub 1. So now when I go to calculate, it gives me that terrible answer again. But when I go to y sub 1, there it is. So hitting graph isn't going to do a whole lot for me. But what I can do to find out what 50 is I can expand my window to like 50, or I'll go 51. I'll go one step further. Okay. When I hit my graph, there it is, way the heck up there. I don't see it, but I really don't need to see it, because what I can do is I can hit second, trace, and go to value, which is 1, and type out 50. And when I do that, I have 129.27142, which is awfully close to 129 watts. So we plugged in the value of 50. If you have all the patience in the world, you could have done second table and gone down to 50. But, you know, that worked. This worked for me, and I lost it. But, you know, what we saw here, in addition to doing cubic regression, is storing our equation into y equals. And once again, if you missed that, you hit stat, you hit calc, you go to whatever regression that you're doing, and when you type it in, you go to store regression, vars, y vars, function, and you store it into whatever equation that you need to, so that when you hit enter, it's there. Okay? All right, let's circle C and call it a day. And we're back, and we got 129 watts. So, yeah, that's that. In an experiment, the number of mold spores can be modeled using a geometric sequence. Very interesting. Where the first day of the experiment is day 1. If the population on day 6 of the experiment is 6,000 and the population is 20,000 on day 10, find the mold spore population on day 8. So what we're going to do, since this is a calculator problem, is we're going to use exponential regression. And once we find exponential regression, we should be able to take that equation and plug in 8 to find our total population. So let's step to the side and do that. All right, so for this guy, we are going to do exponential regression. Start out by hitting stat, go to edit, and we're going to type in the two data points that we have, 6 and 6,000. So let's do 6, move to the right, 6,000. And then we're going to do day 10. So they typed it out, worded it out, whatever you want to say, backwards. So just be careful. We're doing exponential regression, and I'm going to use this equation to plug in 8. So what I'm going to do is I'm going to hit stat. I'm going to go down to 0, which I believe is exponential regression. There it is. But I want to use this equation again. So this is what I'm going to do. I don't really care what the equation is. I just want to use it. So as I hit enter, wherever it stores regression equation, that's what that means. We're going to go to vars. We're going to go to y vars, function y sub 1. Now, yeah, this gives us our equation, but look how gross it is. Wouldn't it be nice if we could just, like, you know, take that and somehow plug in 8? Well, we can, because there it is. By doing that vars thing, it plugs in our equation right there. And in order to find 8, maybe we could just go to our table by hitting second graph and going down to 8 and finding out that there's our number right there. So the answer is B in this case. All right, so since I got the number 10954 point blah, 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 let's round that down to 10954, and then B is going to be our answer. So exponential regression, geometric sequence, same thing on a calculator. Gustavo wanted to increase traffic to his website by buying ads on other websites. 1 month after buying his first ad, he had 4,200 visits to his website. 3 months after buying his first ad, he had 6,048 visits to his website. If the traffic to his website increases by a constant proportion every month, write a geometric sequence to represent this increase. Now, if you're looking at that guy right there, you should be thinking, all right, well, I'm allowed to use a calculator. That guy looks an awful lot like this because they basically are the same. This is exponential regression. So what we're going to do is we are going to run to our calculators and we're going to use exponential regression to write an equation. And then once we have that equation written out, we'll just fix those letters and stuff like that. All right, so Gustavo wants to make a geometric sequence, which is the same as exponential regression. So what I'm going to do is I'm going to go to Stat, I'm going to go to Edit, and I'm going to type in my 2 data points. 1 month matches up with 4,200. Okay, bada bing. Month 3 is 6,048, like so. Now, all I care about is the equation, so I'm just going to quit out of this. I'm going to go to Stat. And again, you're not looking for geometric sequences. Geometric sequences and exponential regression are the same exact thing. So if I hit exponential regression, go down to Calculate, it gives me y equals 3,500 times 1.2 to the x, which, not using the exact letters, matches up with B. All right, so the equation that we came up with is y equals 3,500 times 1.2 to the x. So all we really have to do is, replace y with g of n and n with x. And we're not going to get that one, but we're actually going to get that one, which is B. I don't know why I circled the stuff in A. I just wanted to show that, g of n and regular n. But B is going to be our guy. Population of a town is shown in the table above. Consider the linear population for the town's population and an exponential model for the town's population. So I want to do this using linear regression, and I want to do this using exponential regression. And then once I do both of these, I'm going to see which one predicts a higher population in the year 2025. 2 things. I don't feel like plugging in 2020. I don't feel like plugging in 2022. So I'm going to use 0 for this. I'm going to use 2 for this. I'm going to use 5 for this. And I'm allowed to do that because I don't really care about what the equation looks like. I just care about what I get in the end. So this guy wants us to compare exponential models with linear models. So let's do one of each. You got Stat, Edit. We got to plug our points in. So instead of using 2020, I'm going to use 0 for 2020. And instead of using 2022, I'm going to use 2, which means when it asks me to do 2025, I'm going to use the value 5. Now let's plug in our other points. We've got 2,800. We've got 2,527. And then we'll quit out of it. Now let's calculate exponential first. So we'll go down to exponential regression. There it is. Enter, enter, enter. I am going to use this equation and plug in 5. So I'm going to go down to the store regression equation guy, hit vars, go to y vars, function, and now it's going to store that in y sub 1. So I'm going to calculate it. Boom. When I hit y equals, there's my equation right there with its unnecessary decimals. I care about what happens at 5, and whatever happens at 5, I could just find out by clicking table, and I have 2,166.6. So I'll write that down when I have the opportunity to write it down. That's my one guy. So again, the exponential model gave me 2,166 point blah, 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 blah. Now I'm going to keep the same values. And what I want to do is I want to do the same thing, but with a linear model. So I'm going to go to Stat again. I'm going to go to Calc again. And this time I'm going to go to Lin Reg, which is 4. Enter, enter, enter. I want to store that again in the y equals part. So I'm going to go to Store Regression Equation, the vars thing, the function thing, the enter, enter thing. And now when I hit calculate, that equation right there is in the y equals thing. So I care about what happens in 2025, which means the year is 5. So second table. And now the value that I care about at 5 is 2,107, 117.5. So I'm going to write those numbers down and then come up with my answer in a second. So the exponential regression model gave us 2,167, give or take. Of course, I'm rounding it because of the fact that it's a person, and I want to take 0.6 of a human being. And the linear model gave us 2,118. So this is about 50 some more than that, or in this case, 49 more. So the exponential model is a higher population by 49 residents. That seems to be the answer that I wanted. So I'm going with B, baby. Which statement best describes the exponential function defined above? All right, so we have something in the form a times b to the x minus 3. I don't have to write this out. Now, this is a calculator problem, but I don't think I need a calculator unless I want to use one at the very end to double check my work. G demonstrates exponential decay. Well, this guy wrapped inside the parentheses taken to the x power says, nope, since you're 1.5, that means you're greater than 1. This is growth. So this is not going to be decay, and this is not going to be decay. It's growth because the x-intercept is positive? No. It's growth because a is greater than 0, and b is also positive. So if this was negative, it would take that guy and flip it upside down. But since b is positive and greater than 1, and a is positive, we have exponential growth, so D is going to be my answer. Now, let's throw this into a calculator and make sure everything is good. All right, so even though I didn't need my calculator, let's type it in and see what happens anyway, just to make sure that we got D correct. So I'm going to type out parentheses 1/4. I like to do extra parentheses with fractions because I'm nervous. 3/2 is going to be my growth factor. To the x is right there, scooch to the right, minus 3. And let's hit graph and see if D seems to make sense. G demonstrates exponential growth because A is greater than 0 and B is greater than 1. Well, A is greater than 0, B is greater than 1, and yeah, that's exponential growth, so I'll take it, baby. An exponential function in the form f of x equals a times b to the x has a growth factor of 1.56 and crosses the y-axis at 0.85. On the closed interval 0,4, what is the maximum value? All right, so let's set up our equation first off. We have something in the form a times b to the x. This is going to be your initial value at the very beginning of everything. In other words, the beginning of everything happens when x is 0. So y equals 0.85, a positive number. The growth factor is 1.56, so that's going to be my b, 1.56 to the x. So what I have is I have something in the form of exponential growth. Now it wants me to, on a closed interval 0,4, find the maximum value of f. Well, this is going to make sense that if I have 0 to 4, 4 is going to be my maximum. So what I have to do is I just have to throw that in my calculator, plug in 4, and see what value I get. So we're just going to plug in the equation that we came up with. We came up with 0.85 parentheses 1.56, close the parentheses, to the x power. Now we care about what happens between the intervals 0 and 4. So when I hit graph, that's exponential. And so as you move to the right, your value gets bigger because this is exponential growth, because the growth factor is greater than 1. Now, my maximum is going to happen all the way to the right of the rightmost part of the interval. So basically, my maximum happens at 4. So if I go and type out second trace, hit value, hit 4, I'm going to get that number right there, which matches up with the answer C. So basically, you're finding the maximum knowing very well that your maximum is going to be all the way to the right for this one. And when I did that, I get 5.034, so the answer is C. f of x is an exponential function in the form f of x equals a times b to the x plus c. Select values of f of x are shown in the table below. A is 400. Okay. So a is 400, so let's write that out. F of x equals a times b to the x. A is 400, so let me quick change that. I wasn't thinking. 400 b to the x plus c, which is, I don't know. What I do know is if I plug in 0, that's going to make this part go away and become 1. So what I can do is I need to find c. I need to find whatever c makes this work. So what I'm going to do is I'm going to let x equal 0. And I know when I plug in 0, I get 373. So 373 is going to equal 400 times b to the 0th power, which is 1. If I subtract 400, that gives me c is negative 27. So that gives me an equation of y equals, or f of x equals 400 b to the x, which is what I need to find, minus 27. So what I'm going to do is I'm going to take all of these b values, plug it into my calculator, and test out 400 times 1.25 to the x minus 27 and see if that guy matches up. And if it doesn't, then I'll plug u in for b and try it out. Then I'll plug u in and try it out. Then I'll plug u in and try it out. So let's try a and see what happens. So let's test out a to make sure that a works. The equation that I'm going to use for a is going to be that 400 that I was originally given. A gave me 1.25 as my b, so parentheses 1.25, close it, to the x, and make sure you move to the right and not put it in your parentheses or exponent area. Subtract out 27. Now, in order for this to work, I really want to look at my table of values for 0, 1, 2, and 3. So let's go to second graph. And 0 matches up, and so does 1, and so does 2, and so does 3. Look at that. The answer is A. It worked. Hooray! A is my answer. Oh, how nice. An exponential function of the form y equals a times b to the x passes through the points 529 and 1588. Find the initial value a of the exponential function. So I'm just going to run to my calculator and do exponential regression using these two guys as my two data points. So this one is just a good old-fashioned exponential regression problem. Hit stat, hit edit. My 2 points are 529, enter, enter. And then my other guy is 1588, enter, enter. Quit out of it. I don't need to use this equation later. I just need to find the equation. So let's go to stat. Let's go to 0, which is my exponential regression. And it gives me the equation once I go to calculate. Y equals 16.64 blah, blah, blah times blah, blah, blah to the blah, blah, blah. But the only blah, blah, blah I care about is that 16.6477, which rounds up to 648. The answer is C. So according to this, the A value that I got was 16.648, which is C. Pretty easy. The pH of a substance can be calculated by the formula above. pH equals negative log no base x, where x represents the concentration of hydrogen atoms of the substance in moles per liter. Nifty. If lemon juice has a pH of 2.27, determine the pH of an acid with 2 times the hydrogen ion concentration as lemon juice. Thank you, Lord, we have one of these guys. So let me do two things. My pH is 2.27, so let me rewrite this equation. Instead of pH, I'm going to do 2.27. That's going to equal negative log. Now, since there's no base, I'm going to write out the fact that we have an invisible base 10 and then of x. What I want to do is I want to write that out in exponential form. So the way you write something down in exponential form is if I give you log base b of y equals x, you can write that out as b to the x equals y. Okay, so I'm going to rewrite. Well, first off, let's do this. That negative is bothering me. Let's multiply both sides by negative. Negative 2.27 equals regular log base 10 of x. Using this formula, I can rewrite this out as 10 to the negative 0.27, negative 2.27 equals x. Now, this is how I'm going to finish up this problem. I need to throw that into my calculator and get x equals stuff. Okay. What that does is that gives me the ion concentration of hydrogen atoms and blah, 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 blah. Okay, of that pH. What I want to do is I want to take that. I want to double it and then find the pH of that. So all in my calculator, what you're going to see me do is you're going to see me type this guy out. You're going to then see me multiply it by 2 and then throw it back into this formula up here to get a number. All right, so let's run to the calculator and see what happens when I do that. Well, this is going to be a gross one. You ready? So first thing we need to do is we need to do 10 to the, which is that guy right there, negative 2.27. We need to double that, so times 2. And now that I have that, I'm going to throw it back into that original equation that hopefully you see right there on the right side. So negative log base 10 is negative log. And rather than me typing that whole thing out, a little trick that I could use is I can hit second negative symbol, and it lets me plug in the answer that I just got, hit enter, and I get 1.96 blah, 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 which seems to match up with C. So let me show you what that looks like back on the problem. We'll be done. All right, so in this case, x equals 0.00537 blah, 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 blah. I took that and I multiplied that by 2 to give me 2 times the hydrogen atom concentration. And that gave me the number 0.01074 blah, 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 blah. Okay, so an acid with 2 times that has this, and I need to find the original pH of that. So what I did is I said pH equals, and I typed out negative log regular base 10 of 0.01074, blah, 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 blah. I got 1.96897, blah, 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 which ended up being C. So very unique and challenging problem, pretty difficult stuff. F of x is an exponential function and g of x is its inverse. If f of 4 equals 25 and g of 19 is 11, what is the value of g of 5? All right, well, g is the inverse, right? So f of 4, okay, here's x, here's f of x. F of 4 is 25. Remember with the inverse, whatever point you get, you swap them, which means if g of 19 equals 11, that means f of 11 equals 19. 11, 19. Now, f of x is exponential, which means g of x, its inverse is logarithmic. So this is what I have to do. I have to go over here, and I have to go to my calculator, because I'm allowed to use one, and I'm going to do the ln reg. I'm going to get a gross, terrible equation, but I'm going to use that equation to plug in 5 and see what happens when I plug in 5. Let's take a look. All right, so I have to ln reg this guy. What I'm actually going to do is, I know in the chart that I had on the paper or on the slide or whatever you want to call it, I had just a regular function f of x. What I want to do is I want to plug in my values for the inverse and ln reg that. So I'm going to make sure when I plug these in, I plug in the reverse of them. So 25 gets matched up with 4. Okay, if I were to use 425, I would get an exponential. I want to do logarithmic with this one. I'm going to do 19 Gets matched up with 11. Bada bing. Now I'm going to use ln-reg. So I'm going to go to stat, calc, and ln-reg is right there at 9. There you are, ln-reg for natural log, backwards. Now I'm going to use this equation. So I'm going to go to store regression equation, hit vars, go right to y vars, and go to function and y sub 1. Now when I hit calculate, I'm going to be like, gross, I don't want to write that out. Perfect. I don't have to. Because what I have to do is I have it right there. Boom. Sorry. Boom. Gross. And if I go to table, I care about what happens when G is 5. So where's G5? Right there. And what do you get? 45.0515773. So I'm going to write all that out and going to be done. So I didn't even bother writing that equation down because I don't really need to know it. But what I do know is when I plugged in 5, I got 45.0515773, blah, 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 logs. Fun. A logarithmic function, f of x equals 2 log, no base, I wonder what that means, x plus h plus k has that limit where f of x is going to hit negative infinity as you approach negative 3 from the right. Oh, it also passes through the point negative 2, 4. I have a calculator here. I don't think I'm going to use it. In fact, I'm not going to. So even though it's a calculator, I'm not going to worry about it. This is what I know. Whenever I have to deal with graphing logs and it looks like that, I'm going to compare it to its actual form, f of x equals a log base b of x plus h plus k. It's actually x minus h. Pardon me, pardon me, pardon me, me. Pardon me, pardon me, me. That does change things here. Now, what do I have? A is 2, and that gives me a vertical stretch here. Not really going to affect based off of the two numbers that I see here. We'll get to that in a second. Okay, log base b, again, not going to really affect anything. Log base 10, not going to affect anything. Don't worry about it. This is what I have to worry about, this statement right here. Okay, if the limit as x approaches negative 3 from the right is my infinity, and this guy is positive, that tells me when graphed, I'm going to have a vertical asymptote at negative 3 because this picture is going to go like that. So again, I'm coming from the right to negative 3 and hitting negative infinity. So that's my guy right there. Whenever I have a vertical asymptote, I know that my vertical asymptote equation is x equals h, which means h is negative 3. So part 1, we're done. H is negative 3. Now k is always going to be where your point is 1 unit to the right of the asymptote. It just so happens that negative 2 and negative 3 are 1 unit away from each other. And since negative 2 is 1 unit to the right of negative 3, that tells me that k is 4. So if I were to write out this equation in full, and maybe this is where the calculator would come in handy, even though I'm not going to use it, I would graph 2 log base 10. And remember, the log base, the regular log in your calculator is log base 10. So you can just plug this straight into your calculator. Of x, what did I say h was? Negative 3. So x, in this case, if h is negative 3, this is going to be plus 3. Plus k. K is going to be 4. I would plug this right into my calculator and make sure that it goes through the point negative 2, 4. Now, I made a little tiny mistake here. I'm going to cross that out because they're giving me this version of the formula, which I don't like. I'm not used to that. I'm used to this version of the formula that I created. So in my case, we are going to say that the h that they want is going to be positive 3. So that's kind of annoying. And the k that they want is still going to be 4. But again, the reason why the calculator here might be useful is if you were to graph this guy right here into a graphing calculator and see and double check like your table, because it would go through negative 2, 4. Just make sure it goes through negative 2, 4 on your table, and you'll be in good shape. What is the value of x in the equation above? All right, 3 to the 3x plus 4 equals 9. So let's get rid of 4 and hope magic happens. Well, it doesn't. This is what I meant by magic. Oh, wouldn't it be nice if this was like, 27 or 9 so that I can be like 3 to the 3x equals 3 squared, or 3 to the 3x equals 3 to the anything. That doesn't happen here. So there's not much what I can do except for to write this in the other log form. So the other log form, if I have something in the form of b to the x equals y, I can write that out as log base b of y equals x. You're my base, you are my x, you are my y. So I can write this out as log base 3 of 5 equals 3x. Now, I have no clue what log base 3 of 5 is. And if I run to my calculator, I'm lost because the calculator's log is log base 10. This is log base 3. I have to use the change of base formula. And if you're like, what's the change of base formula? Let me quick show you. Change of base formula says if you have log base b of m and you need to throw that into your calculator, type out regular log of m over log of b. And so this is log invisible 10, and then this will work. So this is what I have to do. In my calculator, I have to type out log of 5 divided by log of 3. That gives me a gross number. That's going to equal 3x. So once I get that gross number, what I'm going to do is divide that gross number by 3, and that gives me an x. So one more time, I'm going to type in log base 5 divided by log of regular 5 divided by a log of 3, get a gross number. Divide that gross number by 3, and that'll give you my x. Okay, log of 5 divided by log of 3. There's my gross number. Divide that by 3, and my answer is going to be 0.488. And I'm going to round it there. All right, so after all of that, I got 0.488. Terrific. The function ln of a of t over a equals kt models the amount of a particular radioactive substance that remains after t hours, where a is the initial amount of the substance, k is the rate of decay. And so a of t would be the total amount when all is said and done. If 24 grams of the substance decay to 8 grams after 36 hours, after approximately how many hours would the initial amount have been reduced to a half? Ugh. All right, so this is going to be gross. This is going to be really gross. 24 is what I start out with. So A is going to be 24. All right. My amount after 36 hours, so T is going to be 36. My total amount is going to be A of T is 8. My job is to find the rate so that when I do find the rate, I can do part 2 here. So I'm kind of doing 2 of these problems in one, which means I'm probably going to have to whip out the calculator twice. NBD, as the kids say, NBD. ln of A of T is going to be ln of 8 over A is 24 equals K times 36. So this is what I'm going to do in my calculator. In my calculator, I'm going to type this guy out. Okay, I'm going to type that guy out right there and get some gross number. Once I get that gross number, I'll have 36 equals k. I'll divide both sides by 36, and then k will equal something brand new. So one more time, I'm going to run to my calculator and find out what ln of 8 over 24 is, get a number, divide that number by 36. That gets me k, which is going to be my rate of decay, something that I'm going to need in order to do part 2 here, right there. Right, ln, there you are, of, what was it, 8 over 24. So let's type that out. It's going to equal a gross number. There it is. Take that number, divide it by 36. And our k is going to equal negative 0.30517, blah, blah, blah. So we'll actually use all of those numbers until we hit that double zero, just to keep things as accurate as humanly possible. All right, so after doing that, we got a pretty gross number, negative 0.030517. Then it was like 008, but I'm going to stop right there. Now that I know k is that, I can go back to this original equation to answer part 2. Part 2 says, how many hours would the initial amount have been reduced to half? Okay, so ln of, now remember the original amount was 24. I'm no mathematician, but half of that is 12. My job is to find t. I now know what k is, so negative 0.030517 times t is going to help me do that. So very similar to what I did over here. I'm going to type this guy into my calculator. When I type this guy into my calculator, I'm going to get a gross number. Then I'm going to divide that gross number by another gross number, which is this guy right here. And when I divide that gross number by a gross number, I get a gross number which represents how much time it takes for this substance to get cut in half. So let's go away and do that again. All right, so this time I'm going to take ln of 0.5 or a half, however you want to write it out. Right. Hit enter on that guy, and it's going to give me that number, 0. Who cares? Negative 0. Who cares? What I'm going to do is I'm going to divide that number by negative 0.030517, hit enter, and I get something to the tune of 22.713, blah, 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 blah. So let's go back, write down our final answer. We can be done with this terrible problem. All right, so after we did that, we ended up with 22 we rounded it to 713. It was like 7134 or whatever. So 3 decimal places is standard for AP, so we'll go with that. Gross. The table presents values for a function f at selected values of x. A logarithmic regression is used to model the data. What is the value of 4.5? So this is what we're going to do. Okay, no work to show here. I'm going to run to my calculator, and I'm going to use ln reg for this guy. It's going to spit out an equation. I'm not even going to write that equation out because I'm going to store it in my phone. And once I have it stored in my phone, I'm going to find the value at 4.5. Okay, so let's go off to the side and do that. All right, so let's do ln reg. We're going to go to stat. We're going to go to edit right away, and we're going to plug in our x values. 1, 3, 5, nope, 7, 9. They had to go out of order on us. 44.9, 37.9, 32.4, 30.7. Now we are using logarithmic regression. So we're going to go to stat, we're going to go to calc, and we're going to use ln reg. So I'm just going to hit 9. Now, Not only I don't need to write out the equation. It's not asking, hey, what's the equation? It's asking when the value is 4.5. So what I'm going to do is I'm going to store my regression equation into y equals so that I can use that equation in a little bit. So I'm going to go there. I'm going to go to vars. I'm going to go to y vars. I'm going to go to function, and I'm going to go to y sub 1. So whatever this gross equation is going to be, I'm not going to bother writing it down because now it's stored in y equals. So since it's stored in y sub 1 and my job is to find what happens at 4.5, I can hit second calc and type in that value of 4.5. So let me hit enter. It's going to graph it for me, even though I can't see anything because the numbers are above 10. 4.5. Enter gives me 35.225, which is going to be A. So let's go back and circle it. All right, so that's ln of reg for you. You got A, pretty standard. I mean, if you've seen my videos, we've done a lot of regression. ln is just another one to throw onto the pile. The amount of bacteria in thousands found on the beach has been steadily declining. Let's go to the beach, beach. Nicki Minaj. Scientists want to create a regression model to show the number of bacteria as a function of years. Calculator problem? Absolutely, because we are going to create a logarithmic regression equation that could model this situation. That requires the use of a little thing called ln reg. So what I'm going to do is I'm going to run to my calculator, type that in. I'm going to get an absolutely awful equation, but let's see what happens when I do that. All right, let's start out with doing our ln reg. We have stat edit, and I'm going to type out 1, 2, 3, 4. I think I can handle that. That matches up with 9.9, 7.8, 6.7, and 5.8. Okay, now ln reg is done by hitting stat, going to calc, and we can go down or we can just hit 9 for ln reg. Now, for part C, I'm going to need this equation again. So what I'm going to do is for a store regression equation, I'm going to go down there, go to vars, go to y vars, and then hit enter, enter, and now it's going to be stored. But what I have to do is I need to take that guy and write it out. Ugh, and it's gross, but we're going to round it to 3 decimal places. So this is saying y equals 9.885 plus negative, so minus 2.939 ln of x. So let's write that out. All right, so let's get rid of that ln reg because we're going to need all the space we can get to write out this awful formula. Y equals 9.885 minus 2.939 ln of x. Now I'm going to use that for B and C. C is actually a whole lot friendlier than B, but that's not the order that we have. B says how many years until there's 2,000 bacteria, which means we're solving for x and we're going to let y equal 2. So let's do that. 2 equals 9.885 minus 2.939 ln of x. I'm going to subtract both sides by 9.885. 9.885. Don't need a calculator quite yet. I can handle this one. Negative 7.885 is going to equal negative 2.939 ln of x. I'm going to divide both sides by negative 2.939, negative 2.939. Now, I'm going to not do as much right now because it's a pain in the butt to keep going back and forth and making these videos when I go to my calculator. So what I have right now is I have that fraction right there, negative 7.885 over negative 2.939 equals ln of x. If I take e to the of both sides, that crosses out, and now I have x equals that number right there. So I'm going to go off to the calculator and find out what that number is right now. All right, part 2 of this problem has me finding out what e to the gross fraction is. So the e to the button is second ln, how convenient. And I'm going to have my open parentheses. It's going to be negative 7.885 divided by negative 2.939. Let's close those parentheses. Let's hit enter, and we get 14.627, blah, 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 and we'll round it to 14.627 years. 14.627, which means how long will it take? 14.627 years. So I don't know, somewhere in June? Pretty unpleasant. C is a lot more pleasant, because now all I have to do is just plug in 6. So y of 6. And what I can do is I can quick run off to my calculator. And since I already saved this in my y equals, all I have to do is just go to the table and find out what happens when y is 6. All right, so as you may remember from part A, we stored our equation into y equals. Okay, so now all I have to do to find out the value at C is I could either go to second calc, trace, type in value, or I can go to my table, run down to 6, and find out that it's 4.619. And since it rounds to 3 decimal places, that's all I've got to do. Ooh, 619, Rey Mysterio. He's a wrestler, a luchador. And you get 4.619. This, of course, is in thousands, so we'll say 1,000. It may have been easier if I just wrote out 4,619, but you know what? I'm sticking with the bit. So there you have it. Gross. Use a regression to determine a sinusoidal model for the data set above. Identify the amplitude of the model rounded to the nearest tenth. So what we're going to do is we're going to go off to a calculator. We're going to type this in, do sine reg, and come up with an equation. Once we have an equation, we'll be able to identify the amplitude of that equation just by looking at the function that we're given. All right, boys and girls, let's do sine reg. Start out by going to stat and then hit edit. We're going to type in our x values, 10, 12, 14, okay, 12, 14, 16, 18, and 20. And then you type in your y values, which is 28, 15.6, 20.4, 35.6, 40.4, and 28 again. The way you do sine reg is you go to stat, you go to calc, all the way down here to C, I believe, is sine reg. Look at it, sine reg. Okay, iterations, don't worry about this. I won't need to use this function later. My period looks like it happens between 28 and 28 happens, my period's 10. So I just figured that out. And I should be able to calculate. And we get the equation y equals 13.007 sine 0.628x minus 3.1388, so 139, close the parentheses, plus 28. So let's go back and write that out and answer the question that they're asking us. All right, so don't ever expect sine reg to be pretty. It never is. But we came up with an equation, and that equation was y equals 13.007 times sine of 0.628x minus 3.139, close it, plus 28. The question here is, it asks us to find the model, so we wrote it out. Identify the amplitude. Well, the amplitude is the number attached to sine at the very beginning. So my amplitude is that 13.007. Okay? So there you have it. A sinusoidal regression. I love it so very much. Like and subscribe. Assume the following data set can be modeled by a sinusoidal function. Estimate the value for the midline of the model rounded to the nearest integer. All right, what I have to do is I have to run to a calculator, throw that in, do sine reg, and use that information to find the midline formula to the nearest integer if I have to do that. I really don't even need, never mind, I'm going to do it anyway. Just watch the video. All right, sinusoidal regression. Let's go to calc, let's go to edit, let's go to stat, and let's go to edit. And let's type in these numbers. 1, 2, 3, 4, 5, 6, 7. All right, we have 7.7. We have, I always feel bad for people who are, just fast forward like 30 seconds and you'll probably be fine. Unless you want to hear me say numbers out loud and hear typing sounds. Or just fast forward 30 seconds. Actually don't, because I don't know if that has anything to do with my YouTube money. Hopefully I'm doing this right, because I'm talking and typing at the same time. Okay. I guess we'll see. All right, those are our values. Now, before we move on, if we're doing sinusoidal regression, we need to know our period, which is between 1 and 7, so our period is 6. Go to stat, go to calc. Will I need this equation later? I don't think I will, because I just need the midline, so I really don't. I just need to see what the equation is. So I'm going to go all the way down to C for sine regression. Don't worry about the iterations part. The period was 6, as we said before, and I don't need to store this, so I'm not going to. I'm just going to hit calculate. Now, there's my equation. It's gross, okay? We'll write this whole thing out, but the key thing here is that 32. So we'll explain what that 32 means in a second. All right, thanks for sticking around, those of you who decided that you were going to put up with that. The equation that we came up with wasn't pretty. Y equals 30.010 sine 1.047x minus 1.991, close it, plus 32. Now, I didn't spend a whole lot of time going over this because I didn't really have to. In this case, what I care about is the value for the midline of the model. The midline happens right here at your vertical shift. So the equation for the midline is y equals 32. So not a whole lot of estimating. I mean, there it is right there in its beautiful, beautiful, beautiful form. You're studying ocean waves with this terrible, terrible, terrible equation right there. Oh, thank you. It's a calculator problem. At what time t will the ocean wave reach a height of 3 meters? So what we're going to do is we're going to graph this guy in our graphing calculator. We're also going to graph where the height is 3 and find out where these two guys intersect. So let's run to the calculator and see what happens. So you're studying ocean waves, huh? Well, let's type out this weird looking function. It's a sine function. So 2, there's my sine. I always get paranoid with fractions, so I'm going to do parentheses pi over 4. So pi is u is pi, divided by 4, like that. Now we can close it. Instead of t, we're going to use x. Minus another fraction, so another parentheses, pi. Pi is u is pi. Divided by 3. Close it again, plus 1. Now, let's get a picture of this. I know we're not done, but let me zoom trig by hitting zoom 7, and that gets me kind of my sine wave right there. At what time t will the ocean wave reach a height of 3 meters? Well, first things first, this is real life stuff, right? So I don't care about negative x values. I don't. So at some point, there's my picture. I'm going to hit 3 meters. So here's 1, 2, 3. At some point, I'm going to hit 3 meters. Maybe, it looks like, probably. So why don't I find out what that time is by going to y equals 3 and then finding out where these two guys intersect. So it's going to intersect somewhere around here. Second calc will let me find the point of intersection. So I'm going to hit second calc 5. My first curve, I'm going to make sure I'm to the left of what looks to be the intersection point. Knowing what I know about altitude and vertical shift, it looks like it's literally going to peak out at 3, because it does. So I'm going to make sure I'm to the right of 3, hit enter, and when I hit enter again, it gives me the intersection point of 3.333333333. So I'll say 3 1/3, I guess. Well, we get ourselves a nice little 3 1/3. So since this is pre-calc, we'll do 3.333. Nothing. No, they don't tell us. Well, thanks, ChatGPT. You blew it. You blew it. So t equals 3 1/3. Fun stuff. A person whose eyes are 5.2 feet from the ground stands at a distance of 21.45 feet from the base of a tower. The person looks upward at the top of the tower with an angle of elevation of 0.13 pi radians. What is the height of the tower? Let's draw this out. This is where you're going to really see my amazing artistic skills. There's our guy. He is looking at a tower. We don't know how tall the tower is. That's kind of the point. All right, so here is a tower. What we do know is this guy is 5.2 feet from the ground. Okay, he's looking up at an angle of elevation of 0.13 pi radians. We know he's 21.45 feet from the base of the tower. So you're 21.45. And my job is to find the height of the tower. So we'll call the height of the tower y because this is precalculus and up and down uses y. So what I need to do is I need to figure out which trig function, SOHCAHTOA, is going to give us the adjacent and the opposite side. Well, tangent does that. So we would say that the tangent of our angle, 0.13 pi, is going to equal y over 21.45. Now, my job is to find y, but that's not going to be it. But I'll get to that in a second. If I want to try to throw all of this into my calculator all at once, which is what I'm going to do, I'm going to multiply both sides by 21.45. I'm going to multiply both sides by 21.45. And so in my calculator, I now know that y is equal to 21.45 tangent 0.13 pi. However, that's not the height of the whole tower. The height of the whole tower is done by calculating 21.45 tangent 0.13 pi. But then on top of that, the fact that this guy is 5.2 feet off the ground. So I'm going to add 5.2 to that, and that will give me the height of the tower if I type it all in one foul swoop. So let's do that. All right, so we did all the heavy lifting on the Google slide video part thing, whatever you want to call it. So now all we have to do is just type that out. 21.45 tangent of 0.13 pi. Pi is u. Close the parentheses. And that gives us the height of the tower without the person's height. So let's add the person's height to it. And that gets us 14.4822. So it's a small tower, but it didn't say it had to be big. It's a small tower. So not a big tower here. You got 14.482 feet. So, yeah, that's what you get. Small tower. The population of rabbits is modeled by the equation r of t equals 182 plus 175 sine 2 pi t over 365, where t is measured in days. On what intervals is the population increasing within the first 365 days? So a very basic view of this problem is this is sine with no shifts. All right, now what's going to happen? I'm sorry, there is a shift. There's a vertical shift. Okay, so I don't know exactly what's going to happen and where it's going to happen. What I do know is its sine, it's going to go like this, and it's going to go like that, and yada, yada, yada. And at some point, I'm going to have an area where it's increasing, and then probably an area where it's increasing again, and maybe it repeats itself. I don't know. But what I need to do is I need to find out where it stops increasing. And it stops increasing at a maximum, and then is decreasing, and then it starts increasing at a minimum. and maybe it happens again, and maybe it happens again. I don't know, but what I need to do is I need to graph this guy in a graphing calculator, find all necessary maximums and minimums, because those maximums and minimums tell me where this guy is increasing, and I have to make sure I follow the rules of 365 days. So let's see what happens. All right, so we're talking about rabbits. So y is going to equal 182, just like that one band who blinks a lot, plus 1, that's a 7, 175 sine, let me double the parentheses. I always get very paranoid. 2 pi r, not r, I'm sorry, t, which is going to be my x. So we'll put that in parentheses, divide that by 365. That's days in a year. We'll close that. And that should do it. So let's zoom trig to get a better viewpoint of what's going on. And I get nothing. And if you're wondering, well, why do you get nothing? Well, because if I'm adding 182, that's a vertical shift of 182. That's a lot. So let's go to my window and let's start out with my y min of, well, first off, my amplitude is huge. So let's keep the y min at 0. If I'm dealing with numbers like 182 and 175, let's attempt 300, and that might do the job. All right. Now, clearly, this ain't going to do it. Why? Well, it also mentions numbers like what's happening within the first 365 days, and it looks like I don't have 365 days. So let me make my window go from, I don't need any negatives because negatives mean negative time, and that doesn't make sense. So let me go to I'm going to the wrong thing. My x max, let's do -1. And let's do my y max at 370, just, to go a little extra. Just to go a little extra. All right, so let's bump our window, our y max to 400. And that should hopefully give me what I need to see. Yes. Now, I care about when this is increasing. So it looks like it's increasing. And I said this in the part beforehand. I need to find out from here to its max where it's increasing. Now, clearly it's increasing, and it stops increasing at the max. So I have to find the max right here. Now, it's going to decrease until the min and starts increasing until the very end. So once I find out my maximum value and my minimum value, I'm good to go. So second trace maximum will help me find my max value. So let me scroll to the left until I go to the left of my maximum. There. Enter. Let me move to the right of my maximum. Enter, guess, enter. And it's going to tell me that the maximum happens at 91.2599. So 91.260 is going to be a maximum value. Just writing that out so I can write it back down. All right, let's find my minimum value. Same idea, but min. Second, calc. Minimum is 3. So let's move to the right a bit, go to the left of my minimum, move to the right some more, hit enter on that, hit enter on that. And my minimum is a beautiful 273.75. All right, so my maximum number was 91.260. My minimum number was 273.75, and this picture that I drew out ended up being pretty nice. So I'm, a little pat on the back for me. Now, the way I write that out in interval notation is it begins increasing right away. So I will include 0. And it goes all the way to 91.260, but I won't include it because that number technically goes on forever. Then I've got union. Now it's decreasing for a while, and it picks back up again at 273.75 exactly, and then goes all the way up until 365 days, including. All right, so those are my intervals where these guys are increasing. Fun stuff. Rabbits. Consider the sinusoidal function. Find the x values of the minimum values of the function on the interval 0 and 4 pi. So this is a cosine, but it's a mess. So, we're going to have ourselves some kind of periodic function. I care about the x values where I have my maximum. So whatever the picture looks like, and using the fact that this is only between 0 and 4 pi, I'm going to try to find the maximum values between those numbers, 0 and 4 pi, in my graphing calculator. So let's see what happens. Well, this one's a doozy. Let's just get right to it. Y equals 4.651 cosine 0.833. There's my x minus 1.239, close parentheses, plus 4.101. This is my favorite amount of Dalmatians. Now, what I'm supposed to do is I'm supposed to find the x values of the maximum value or values on the interval 0 to 4 pi. Now, looking at this, my numbers are gross, but they're not huge. And I'm looking at the amplitude rather, and the phase shift. The phase shift is around the 4 range, and the amplitude is also around the 4 range. So before I do much, let me zoom trig and find out that that picture is probably not going to be good enough. See? And now it gives me an idea. I need to find my maximum value. So it looks like my window, I'm probably safe for -1. Probably safe there. Not that I care because I need the max value. And let's go up to 10 for my y max. And hit I'm not going to hit graph yet. What I'm also going to do is I'm going to make sure that my interval is where it needs to be. So let me set it at -1. This is supposed to be from 0 to 4 pi. So let me go from -1 to 5 pi. Okay? Now I can graph. Much better, much better, much better. So between 0 and 4 pi, I have 2 maximums, it looks like. 2 maximum values. So let's find them. Let's find the maximum the first time. So let me go to second trace and hit 4 for maximum. Let me go to the left. Okay. Enter. Enter. And that gives me an x value of 1.487. Okay, so that is one of the x values that gives me the maximum given the intervals 0 and 4 pi, 1.487. Now, the other one is going to be done by doing the same exact thing. Second calc maximum. Let's move to the left. Move to the left some more. Guess always hit enter, and we're looking at 9.0392, so 9.039. Those are my 2 guys. So I had 2, and those 2 x values were 1.487 and 9.039. Good job, everybody. Thanks for watching. All right, so in order to graph this crazy looking polar function, the first thing I need to do is go to mode and make sure my function is set to polar. When you do that and you click y equals, you'll notice that it's r's now. So we can start typing away. 2 minus 2 sine theta. And if you're like, don't you mean x? Nope, when you're in polar and you hit the x button, it actually gives you theta. Isn't that nice? So let's close that, plus sine theta again, close that. Let's open up a parentheses and do the square root of the absolute value of cosine. So math num gets us our absolute value. Okay, we're going to put cosine theta right in there, close the parentheses, hit right a bunch of times until you're definitely out of that square root, and now we can close the parentheses. The parentheses, not really too necessary. let's divide by sine theta. Did I put two thetas? I think I did. Sine theta, close the parentheses, plus 1.4, close the parentheses. Now that should do it. Let's make sure that my mode is set to radians. It is. If I hit graph, that's what I get. Now that I could zoom a little bit. So let's zoom in and see what I have. Okay, let's move down so it centers things nicely when I hit zoom in. And let's see what I have. It's a heart. Aw, I made you guys a heart. You know why? Because this is the last problem of my random AP Precalculus example problems that I stole from the internet. And I love you guys for watching my videos. So this is me showing my affection the only way I know how. Math. Thanks for watching. Love you. Bye.